Okay. Now, this is chapter 12, which is the contents of week 3. As we agreed before, we'll go through this chapter virtually. It's mainly a theoretical chapter. It's a very good candidate chapter for the multiple choice and the true or false questions in your midterm exam. So please study this chapter very well, understand it very well, and make sure always, as I don't want to repeat myself, but please make sure that you can answer the self-check questions always, okay? Now, this chapter is mainly about the software development cycle, and the development cycle is here using object-oriented design. So again, it's the software development cycle all using object-oriented methodologies, okay? Here we go. So these are the goals of the chapter. First, to learn about the software life cycle, and then to learn how a software, for instance, like the Blackboard system, this is a software. So just imagine yourself that you are at the beginning of developing such a software, starting from scratch, totally from scratch. So this development cycle has different stages. This is what we will be going through. Then you need to learn how to discover new classes and methods, okay, when implementing this software. And then something called, to understand CRC cards, so we'll explain them shortly. And then you need to be able to identify the relationships between the different classes that you define for your software. These can be inheritance, aggregation, and dependency relationships. And then you need to know exactly the notations of the UML diagram. The UML is the Unified Modeling Language. Okay, so using the UML, you will be able to draw the classes that you need for your software, and also draw the dependency and the relationships between these classes. Okay, and then finally to learn how to use object-oriented design to build complex programs. Okay, now the software life cycle is as expected. I think you already have gone through this before, maybe in one of your courses. First, you start by analysis. So you start analyzing the user's requirements. What do they need from such a software? Then you start designing the software. Then designing here means designing what classes, since this is an object-oriented software, so what classes will I need for the software, etc. And then start implementing the defined classes. And then you test your software. Implementing means here you start writing your code until you have a runnable program. And then you test your program to make sure that the output is already correct. After the testing phase, you just deploy the program, by meaning that you publish the final product and give it to the user to install. Okay? So here we go. For each life cycle, okay, for each stage in the life cycle, the analysis, design, implementation, testing, and development, there is always an output. So make sure always that you understand what each part of the life cycle is doing and what is the output from each life cycle. The analysis, as we said before, the main output of this phase is to define the requirements document. Requirements document, this defines what the programs will do once completed. Of course, you define these requirements by asking your users. Then you will have also an output for this phase is the user manual, which tells how the user will operate the program. And then finally, the performance criteria, which determine how this program is operating, whether this program is operating well or not. Okay? So it's mainly defining what the project is supposed to do. In the design phase, you start discovering the structure of your system. Okay, this goes by defining the classes that you need for your system and which methods will be defined in each class and what is the relationship between the different classes. Okay, so the output mainly here is the description of classes and methods, and you will draw diagrams showing the relationships among the classes. What are the diagrams here? You will be using here the UML language, which is the Unified Modeling Language. Okay. Then the implementation, well, you will be writing the code, and the output here is that you have a runnable program, which is a completed program. Then the testing, you will keep testing the program to make sure that everything works correctly, and the output is you will have a report of the different tests that you have made and their results. Finally, the deployment is like, so users install, you give the final product to the, you publish your software, you give it to the user to install it and to use it for the intended purpose. Okay? Now, this is what we call, now we have explained the main phases of any software lifecycle development. Okay? Now, is the sequence important for these phases? Yes. Do they have always to be in the same sequence? We'll see. The first thing we have here something called the waterfall model. Okay? The waterfall model is a very simple sequential process of what we have just mentioned, the analysis, design, implementation, testing, and deployment, as you can see here. Okay? So this is a very basic one. Now sometimes if the software is very simple, we can do it that way. However, if the software is really complex, sometimes if we follow this waterfall model, we might not reach the correct result. Why? Because if you finish the analysis, and then the design, and then you implement, and after implementing you start testing, and then you give it to the user, sometimes once you give it to the user, it will tell you, no, I'm not satisfied with this end product. Please go back and change this and that. So at which stage you should have stopped? You should have stopped at this stage after designing. You may go back again to the user and tell him, are you satisfied with this part or not? And if he is satisfied, then you start implementing it, and then you go back. So this model that I just was talking about is called the spiral model. So again, now the first basic one is the waterfall model, very sequential. The second is called the spiral model, where we have multiple iterations. Okay, and where we actually construct a prototype, small prototypes, until we finish the end product. And this is how it looks like. Now, I can divide my software into small prototypes. So if the software is designed for doing, for instance, 10 functionalities or 10 tasks, then I can implement task by task by doing the following. First, making a small prototype, so I'll go through the analysis phase, the design, the implementation, testing, and give the final product, but in terms of a small prototype. Once this prototype is done, then I go to the second and I do the same iteration again. And then the third, etc., until we reach the final product. So for each prototype, after I finish it, I just add on it the different features that the user is requiring, and then I'm implementing the whole thing again. Okay? Is that clear? The spiral model, is it clear for everyone? Okay. Please, I need to see the feedback. When I ask a question, please tell me the feedback. I need to see it for everyone. So please make sure that you check either the green mark or the red mark. Okay? Avoid the chat, please, because if this is just a simple question of yes or no, just check. Okay? Now, this graph shows another another model for developing software. This model has been actually invented and defined by the inventors of the Unified Modeling Language. You don't have to go through the details, but as you can see, there are many iterations here. This is again a type of a spiral model. As you see here, now I have the business modeling phase. I have then so you start modeling the business requirements. Then you define the requirements of the users, then analysis and design, implementation, testing, and deployment. And for each of these phases, you have different internal phases, whatever they are called: inception, elaboration, construction, transition. You don't need to know much about the details. But as you can see here, this is a very complicated modeling process for modeling complex software. And this one has been invented by the inventors of the UML language, and it has many iterations. So again, the main concept here that this one has many iterations, similar to what? Similar to the spiral model. Now, Another methodology for developing software is called extreme programming. It's called extreme programming. Now this is a methodology. This methodology has been invented by the UML inventors, and this one is another methodology that is used also by programmers. It's called extreme programming. Now the main thing about this methodology for developing software is simplicity. It strives for simplicity. It focuses mainly on best practices, and it removes the formal structure. Meaning, once the customer is always on site with the programmer, so there is always a constant relationship between the programmer who's writing the code of the program and the customer who's using or who's requiring the software. So whenever the customer requires a certain task, the programmer goes and performs this task and is in constant contact with the customer to make sure that the customer is satisfied. Okay? So using that technique means that the customer makes the business decisions, and then the programmer makes the technical decisions, and then the programmer keeps updating the plan when it conflicts with reality. Okay? Then also this means that the programmer will not finish the complete project and then deliver it to the customer. No, the programmer will keep giving the customer small releases of each different task. So this means the system will be very useful system very quickly, and also there is a release update on every short cycle. The metaphor for this extreme programming is that programmers have simple shared story that explains the system. Also in extreme programming, again we mentioned the simplicity feature. Regarding the testing, the programmers and customers write test cases, so programmers and customers actually work jointly and they keep continuously testing the program. Okay. Once there is anything that needs to be rewritten, then this is called refactoring. So restructure the system continuously to improve code and eliminate duplication. Now there are three types of extreme programming. It could be either pair programming, where two programmers write the code on the same computer. It could be collective ownership, which means all programmers can change the code whenever it's needed to be changed. And also the third thing is continuous integration, which means that after they build the system, they test it, and whenever a task is complete, they build each task, and then they test this task once it's completed. Okay. Again, very important features. So this on-site customer, so the customer is always there with the programmer. Coding standards, the programmers follow always the same standards to have a final documentation for their code. Okay, and that's it. Now, a very important question before: do you think what type of modeling is that is extreme programming? Now, extreme programming is a methodology. Now, what type of modeling is it using? Waterfall or the spiral model? Which one do you think? Waterfall or spiral? Spiral, yes, Noor. Anyone has another recommendation, waterfall or spiral? We said waterfall is just very sequential analysis. The analysis phase is done for the analysis phase for the whole project is done, then the design, then the implementation. Once the implementation is done, the user, then we go through the testing, and then finally the user gets the whole product. In the extreme programming methodology, in the spiral modeling, there is always an iteration. There is always an iteration. So you keep producing small prototypes, you give it to the user, test it. Once it's done, you go to the second part. So again, the question is, the extreme programming methodology, is it a spiral model or a waterfall model? I need someone else beside Noor. Okay, everyone's saying now spiral. Yes, it is. Exactly, it is spiral. So I guess now you have you can all differentiate between the spiral and the waterfall. So in case you get any question that describes a case of a certain methodology of developing a software, so you can now define whether it's waterfall or spiral. Okay. Now, we need to focus now a bit on the design phase. As we agreed, we're designing using an object-oriented methodology, so the design phase now has a bit more details that we need to discuss. Now, in the design phase, we said we will discover the classes that comprise our program, the responsibilities of each class, so what shall each class do, and when I say responsibilities, so I mean here the methods that are embedded in this class and its behavior. And finally, we describe the relationships between the different classes. Okay. So, how do you discover classes? We have here a couple of hints. Now, a class represents some useful concept. It's like an entity in itself. For instance, as we mentioned before, a bank account. Why do we call it an entity? Because a bank account has a separate behavior. It can have a deposit, it can have withdrawing, it can have it has lots of methods that we can include in this class. Okay, so concrete entities like bank accounts, like product. Okay, why product is a concrete entity? Because a product has a number, it has a name, it has a description. Okay, it has a production date, it has an expiry date. For instance, if it's any durable good or whatever, a non-durable good. Okay, so here this is how you define what entity could be a class or not. Other classes could be also abstract classes, like what? Like window. You remember when we designed our graphical user interface? And we said like a class could be a frame is a class in itself. So this is an abstract class, abstract concept. Okay. Also, a class is always has a noun. So if you say, for instance, to deposit, so this shouldn't be a class. Deposit here is a verb. So this is only performing a certain function. But if I say bank or bank account or product or triangle, so this is a noun. So always look for nouns if you want to find a class. Okay. Then define the behavior of each class. So this means what each class should be doing, and the methods, and find the methods by looking for verbs in the task description. So again, if you want to discover a class, look for nouns. If you want to discover a method, look for what? Look for verbs. Okay. Now this is an example here where we have an invoice. Assume that someone tells you, please print the invoice for a certain product or a certain line item. Now, can you define here what classes could be we using? First, candidate classes could be invoice. So I have a class that is called invoice that has a certain behavior. Also, the item itself, the line item itself, it can be a class as well. It's an entity. The item can have it has a separate entity, and it can have a separate behavior. What else? Maybe the customer, because this invoice is always produced for a customer, so maybe we have a customer class as well. Okay, can you see here? Sam's Small Appliance, and this is an address of the customer. So maybe we're using here also a class called customer. Okay. So this way we are trying to discover where the classes could be. So as I mentioned here, classes could be invoice, line item, customer. Okay, and it's a good idea always to have a piece of paper and you write all your candidate classes, and then you start filtering these classes and see whether they could be used as classes or not. Okay. Now, when finding a class or when trying to discover a class, always keep the following points also in your mind. If you find an entity that has multiple occurrences in the problem description, then these are good candidates for classes. I'll tell you an example now. Now let's imagine that you're trying to have a sales system, okay? And in this system, the customer is always mentioned. So, for instance, you're saying I'm selling this product this and this product to this customer, and product 4 and 3 to customer 2, and product 6 to customer 4, etc. So you see how many times is the word customer occurring. Okay, so if I have a multiple occurrence of such an entity, then this is usually a class. Same wise, I have also mentioned the word product several times. It's a noun, and it has its own behavior, and and again there is multiple occurrences of products. So again, this could be a good candidate for a class. Okay, once I do that, I say I have a product, I have a customer, then I start finding out what all objects or what all occurrences have in common. So I have now product 1, 2, 3, and 4, etc. So what do they have all in common? I might go more into details and say, of course, all products have something called name. All products have something called number. All products have something called description, etc. What about the customer? All customer occurrences have something called name, address, maybe ID. Okay? So everyone's following so far? Everyone's following? Okay. Now, when you come to representing these entities as objects, sometimes they are objects and sometimes they are primitive types. Do you remember what is a primitive type? Okay. Now, if, for instance, I have something called address. Now, the address could be a class in itself or could be a primitive type. How come? If I decide that I want every single detail about the customer address, so I need to know the city of the customer, I need to know the for instance the street number, I need to know the area, okay, of this address. So it's like dividing the address into more properties. So in that case, I will define the address as class. However, if you don't care about these details and you just want to know the string address or the text, only the text address of this customer, so you will just use the string data type or primitive type. Okay, so please make sure what you need first, and then you decide whether it could be a class or an object, or it could be just a primitive type. Okay. Now, another thing is called CRC card. The CRC card is when discovering or when finding out your classes, as I told you, it's a good practice to have a piece of paper. Now, this piece of paper is called CRC cards. Actually, you can have a piece of paper, or you can, of course, write it on your computer. It's like a card where you describe the class. So this is the abbreviation: class, responsibilities, and collaborators. Okay. Now, it's a card for each card represents a class, and in this card you will write the responsibilities of this class. In other words, it's the methods that are performed in this class, and its collaborators, meaning the different classes that this class is dealing with, or the different classes that this class is using. Okay, and then you will have like an index card for each class. And then you define the methods which you're using the verbs in each card, and then you write the responsibility on the class card, etc. Here we go. Now, this is a card for invoice, for the class invoice. So this is the CRC card, the class is invoice. Now, one of the responsibilities of this class, which is the invoice, compute the amount due. So this is a responsibility. You see, this is a verb, it's a method. Or actually, it will be defined as a method later on when we implement that in the implementation phase. Then I have something called line item. So this class, which is called invoice, is dealing or is using something called line item. Line item itself is another class. So invoice is collaborating with another class. So this is called collaborators. So whenever you have any other collaborators, for instance, I can write here product. I can write here also customer. So these are all collaborators for the class invoice. What about the the responsibilities complete among you, maybe print or whatever, okay? Now this is a good question also. Suppose the invoice is to be saved into a file. So suppose we're going to save this invoice in a file that will be printed later on. In this case, a candidate collaborator will be the print stream clause, okay? So I will be dealing with the print stream clause. Now, okay, as I said, we have each clause has its collaborators. But what is the exact relationship between each clause and its different collaborators? Now we have three types of relationships. We have the inheritance, which is translated into is a relationship. Okay, we have the aggregation, which is okay. First, dependency, which is the use relationship. And also we have the aggregation, which has a relationship. Okay? So either a clause is another clause, so it inherits from another clause, or either a clause contains other clauses, so this is called has a relationship or aggregation, or dependency, either a clause uses a relationship, uses a different clause, which is called a dependency. Okay? Now we go here further. The inheritance is a relationship. Please note this word because you can be asked about it. Okay? Now, meaning what? That a clause can be general, which is the superclause, and another one which is specialized is the subclause. As we know, the subclause inherits from the superclause. Okay? So, like we said before, every savings account is a bank account. So you see, this is a relationship. Every savings account is a bank account. Every checking account is a bank account. Also, every circle is an ellipse. So again, it's an inheritance relationship. Now, can we say something like, should the class tire be a subclass of class circle? You know what a tire is. A vehicle tire, for instance. Can we say that this is tire is a subclass of class circle? Not actually, because usually a tire has a couple of things, including the circle. So a tire has a circle, but it does not inherit from circle. Okay, so it would be more appropriate to use the has a relationship, which is the aggregation, which we will explain now. Now the aggregation is the has a relationship. Again, learn this by heart. The aggregation means it has a relationship. Example is the tire that we have just mentioned. Aggregation means that objects of one class can contain references to objects of another class. Meaning, I have a class, and in this class I am referring to other classes. Like here, for instance, the tire, the class tire. In the class tire, I have rating, private, so it's referring now to the string class. Boundary, which refers to a private string, private circle boundary. So I'm having an object, or I'm making a reference to an object of type circle. So the tire now has what? It has a circle object. So every car has a tire. In fact, it has 4. This is another example for aggregation. If I make another class called car, so a car has always what? Has always a tire. And a tire has what? Has a boundary of type circle. Do we understand the term aggregation? That has a relationship? Everyone? Okay. Now what about this rest here? Now this is a very good example. And very important actually for you to know the UML notation. As I told you, what is UML? UML is a unified modeling language. Okay, it gives you standard notations or standard drawing notations for drawing the relationships between object-oriented framework. So it gives you it tells you how to draw the relationships between the different classes and objects. Okay. Now, please note the following. Now, a car inherits from vehicle. So a car is a vehicle. So the notation for inheritance is a closed triangle, a solid closed triangle, and make sure that the triangle is up. Actually, it has a direction to the vehicles class, because why? Car is a relationship. If you reverse this triangle, so this means that vehicle is a car. So this is wrong. Car is a vehicle, so the triangle here is up. Now, what about tire? We said that car has a tire. The car has a tire. So you see how it looks like? We have here a diamond, so it's a solid diamond. So to say that the car has a tire, so this is how it looks like. We start by the car. The diamond is directed to the car here, so the car has a tire. Okay? Finally, the dependency. Dependency means the user's relationship. Okay. For instance, many of our applications depend on the scanner class to read input, as we did in our very last program in the recursive method of the Fibonacci series. We used the scanner class to read input from the user. Okay. So now, what are we doing with the scanner class? We are using it. It doesn't mean that the Fibonacci class has the class scanner, no, but it means that it just uses the class scanner. Now, someone would tell me, but this is very similar to the aggregation. Yes, actually, it is very similar, but the aggregation is just a stronger form of dependency. We just use the term aggregation if the class has really another component. Has another class. So if class, for instance, I have class 1 and class 2, if you are sure that class 2 is a basic component of class 1, then this is called aggregation. If not, if it's just using it for a certain purpose, then this is called dependency. Okay? Yes, Omnia? The mic is open if you want to talk, or you can write the chat. Dependency like to interface concept? Like the interface concept? No, actually not. Because I'll tell you an example. Okay, where in our interface, yes, it means we use the class. But I'll give you an example. Now, remember when we said that we have the bank account class and we have the savings account class? Okay. Now, and we also had the interface that is called measurer. And what else? Okay. Now, the bank account class uses the bank account class implements the interface measurer. Actually, there is an example, a good example here. Just give me a second. In chapter, this is a very good question, Umnia. It was in chapter 9. Here we go. I'm just returning to our first example of the interfaces. Okay. Here we go. You see this diagram? Okay. Now, data set here. Okay, just give me 1 second. I'll just finish the notations and then I'll go back to this diagram. The notations here, because there are some notations here that you don't know the meaning of. So first, if I have here inheritance, So the inheritance means a solid triangle. If it has an interface implementation, so you see, Omnia, the interface implementation itself is a different category in the UML. So the interface implementation has a closed dotted triangle. A closed dotted triangle. The aggregation, it has a diamond, a solid diamond, and the dependency, it has, which is the users, it has an open dotted triangle. Okay, Omnia? So now, if I go back to my example of the interfaces, we have the bank account class, we have the coin class. Okay, both of them, they have implemented the interface measurable. So you see what am I using here? I'm doing a dotted closed triangle. Dotted closed triangle here. Dotted closed triangle. Then the data set, what is it doing with the interface measurable? It is using the interface measurable. Why? Because it's not using anymore the bank account, it's not using anymore the coin class, but it is using the interface measurable, which is implemented by bank account and coin. So this is why we are using here what? The open dotted triangle. So the four different relationships, are they clear now? So Omnia, is it clear for you now? Yes, okay, perfect. So now we continue. Okay, this is a couple of self-checks. Please make sure that you know them. Now we mentioned the classes or the relation, how we write the notations of the relationships between the different classes. Now, what about the attributes and the methods? Okay. Now, actually, we have written that before, and you have seen that before in our PowerPoints, but we didn't just mention that this is called UML. So this is how you write it. This is the a rectangle which contains the class name, the attributes, which in my case balance, and the methods. Please make sure that you always make the brackets or draw the brackets beside them to show that these are methods. That's it. Okay. Now, the relationship. The relationship, it can have something called multiplicities. What do we mean by that? Okay. Now, I know that a customer, okay, so someone can tell me what this notation is. This is an aggregation relationship. Why aggregation relationship? Because I say that a customer has a bank account. So this is, again, a closed diamond. Now, the question is, can a customer have one or more bank accounts? If yes, then I'll put here beside the bank account 1 dots and star. So 1 dots and star means one or more. Any number, which means 0 or more, so only 1 star. 0 or 1, so 0, 1. Exactly 1, so it will be 1. In my case here, I know that a customer, if I have a customer in my bank, okay, then the customer can have one or more bank accounts. So this is how we write the relationship here. All right. Now, another terminology that is very similar to aggregation is called also association. This is a just more general relationship between classes, and we use it in the early design phase. So when you design your classes, you just make sure that these classes are serving each other. But when you go into more details, so you call that association. For example, here, bank, customer. You know that the bank is serving a customer. Does this notation make any sense here for the UML? No, this is a solid open triangle. So you are just showing that there is an association, a relationship between the bank and the customer. Now, how this relationship is actually like, you define it when you go into more details. Can anyone tell me what is the relationship here between bank and customer? The bank is a customer, or the bank has customer, or the bank uses customer. What do you think? What do you think? Bank is a customer, or bank has a customer, or bank uses customer? Huh? Yes, exactly, Noor. The bank has. Exactly. Now, the bank has only one customer or one or more customers. It's actually one or more customers. So, if you want to define it with more details using the UML, here you go. So it will be like that. Okay? But here we have the bank and here we have the customer. And it will be one or more actually. If you want to just make it very general, you just say bank serves the customer. How and what is the relationship like? You can define it later on. All right. Now, there's also something called the part development process. Now, in the design phase, again, in the design phase, you have something called the part development process. First, you gather the requirements. Then, use the CRC cards that we have just explained. Then, you use your UML diagrams to draw your CRC cards. After that, you use something called Java doc. Okay, the Java doc is actually a tool in Java that you can use to document your code. What do I mean by documenting? It's like before every method you will be putting some comments. Have you seen the code that I have sent you? If yes, you will see that before every method I'm making some comments to explain or describe what this method is doing. So when you call now the Java doc tool, it will take these comments and make a separate document for your class. Okay? And then you implement your program. So this is a file development process in object-oriented. Please make sure that you know them by heart. Now, this is a case study. We don't need to go through it, but you can just read it and see. It explains also the exact terminologies and concepts that we have just mentioned. Okay, so it goes with you step by step and tells you what are the candidate classes, and then what is the behavior of each class, and etc. And how do you write the CRC card, etc. Okay. So please go through it. We don't have to go through it together. It's very simple. Okay. Now, here in this case, now if you remember this, the invoice, this is a UML diagram for the invoice program, or for actually the program is called printing an invoice. Now, in order to print an invoice, this is the output of the case study. I just need you to focus on the following. I have here the class invoice. Now, the class invoice, okay, uses the class product. Why it uses the class product? Because it calls the item for which the invoice is printed. Also, the invoice, okay, has an address. So it's an important component of the invoice class is an address. So it has an address. An address is another class itself. So this is an aggregation relationship. What about the line item? Each line item has also an invoice. What about the line item as well here? Each line item has also a product. So just make sure that you understand here the UML notations, okay, and relationship. Okay. Now here it describes how the documentation goes. We don't need to go through all this, but please make sure that you read it well and understand it. It's very simple. By the way, if any one of you has, for instance, if you go to the Java library and you search, for instance, for the definition of any method online, okay, maybe I can show it to you here. Just a second. Give me a second, please. Okay, I will share with you here my page, my Explorer. Now, this is what I was actually looking for the definition for the print stream class in Java. Okay, so here we go. It's called, for instance, class print stream, and this is how it's written: public class print stream. It extends filter. It implements two interfaces, whatever. Okay, and now you see it has the constructor. This is the constructors. It has methods. These are the methods. This is the description for each method. You see what is that? Actually, this is the output of calling the Java doc tool. What has happened is, while I'm writing my code, I'm commenting each part of my code, putting some comments in a certain way, and then when I call the Java doc tool, it takes every comment and generates such a document. So it's very organized. It's like a hierarchy. Shows you where the class is, in which library, the component, what the class is extending and what it is implementing. It shows you the constructors of this class. It gives you a summary of each method, you see. So this is what we call the Java doc output. Is it clear for everyone? Is it clear for everyone? Okay. So now I will go back and share my my PowerPoint again. Here we go. And so you see, when they did when they called the Java doc for the class invoice, you see this is how it looks like, an HTML format, and it shows you the different classes and what it is inheriting from, and the constructor summary, method summary is the same that I have shown you. Okay. So it's a very organized way for documenting your program, actually. Now we go further. Now, actually, this is an implementation of the case study. Again, I will not go through it, but it's very easy. You will just see the case study is very efficient and very comprehensive for you. So once you read the case study, you understand it. You start then your design phase by using the CRC cards, okay, and you draw the diagram, and then you start writing the code, which is in this phase. And then you produce the output. So we don't need to go through all that. Okay. And this is again another case study, which is an automatic teller machine. Again, the ATM is used by bank. The case study states the following: the ATM is used by bank customers, and we know that a customer has a checking account, a savings account, a customer number, and a PIN code. Okay, so if you're a customer now, if any one of you goes to the ATM, it asks you, do you want to access your checking account? Do you want to access your savings account? What is your customer number and what is your PIN code, right? So now, how can we translate this into a program? Okay. As we said, the customer can select the account. The balance of the selected account is then displayed. Then the customer can deposit and withdraw money. The process is repeated until the customer chooses to exit. So this is again the case study. Okay. Now we have here two separate interfaces. The GUI, the graphical user interface, that closely mimics the actual ATM, and we have here a text-based interface. So we have here, you can use here two separate interfaces, either graphical user interface or just a text-based interface, which asks the user some questions and the user just answers the input. So in this case, you can implement the program in two ways, either using graphical user interface or just using the scanner class. Okay. And this is the graphical user interface here. This is how it looks like, and this is the text interface, which lets you enter customer number, press the A button, display shows, etc. Okay. Now, of course, you will reach a part where you have now to design your program or your CRC cards. So in this case, possible classes or candidate classes, you will search now for nouns. The ATM can be a class, the user can be a class, the keypad, if you are using now the graphical user interface, the button, the state, the bank account, the checking account, the savings account, customer number, PIN bank. Are all these classes? Not necessarily, but you're just writing down what could be classes, and then you start filtering. How do you start filtering? By writing your CRC card. When writing your CRC card, you will understand the behavior of each class. If you see that one of the candidate classes that you have written here is not really a class, like for instance the customer number, okay, then you will delete it, etc. Okay? So these are just mainly case studies. Okay? And this is actually a state diagram for the ATM class. This means the flow. This is not the process development. This is the flow of the functions in my ATM case study. So here the start, the customer number is entered. So we are using now the PIN code. The customer number is found. So I'm opening the account class. If the account class, then I can make a transaction. I go back to the account, and then if I choose the exit, then I can go out of the program. Okay. That's it. Now again, the UML diagram. This is very important for you. Now, I have some. If I'm using the graphical user interface, so now I have an ATM class. The ATM class has, so this is an aggregation relationship. The ATM class can have more or has one or more has only one bank. You see, because when you go on the street, you go to any ATM machine, you can use the ATM machine for one bank. Sometimes you can use the ATM machine also for one or more banks, like the 1, 2, 3. Okay. In my case, it uses only one bank. So the ATM has only one bank. Now, the bank uses what? Oh, in my case here, the bank has here 0 or more customers. And again, the customer, in my case, since a customer can have a checking and a savings account, so a customer has 2 bank accounts. So you see here 2. Now a bank account, all right, has an ATM, etc. And this is the graphical user interface. An ATM has an ATM frame, and the ATM frame has also a keypad. So again, we go here to the UML diagram. And then you go back to the documentation. How do you document it? And how do you write the documentation? Okay. Now, please make sure that you know how to write that. For instance, if I want to describe what this class is doing, so an ATM that accesses the bank. So this is the description. So this is how we write the comment. If I want to explain the constructor, I say here, constructs an ATM for a given bank. And then it's important that you write this keyword, @param. @param means that it's taking a parameter called a bank, okay, to which the ATM connects. If you don't write this keyword, the Java doc will not understand you. So this is how we write just the notations. It's very important that you know that, okay? Again here, if I want to, the method that's called select customer. Now how do we define it? First, I'm doing my comment here, 2 stars, and then I end it here. So if someone does it that way, this is a right comment, no problem. The compiler will accept it. But if I wanted to do it for the Java doc, so please don't forget the second one, okay? So this means find a customer in a bank. If found, that you just state what's doing, all right? Again, don't forget, if this method is taking a parameter, you just write the word @param, pin, the pin of the current customer, etc. Okay? And this is the implementation of the program. Again, you can go through it. That's it. Again, make sure that you know the self check. And the answers of the self-check questions and the answer of the self-check questions. Okay? So I think we have gone through the main points of the chapter now. Any questions before I stop recording regarding this chapter? Any questions? Okay, perfect.